Hi, in this video, we will have the differentiation rules 5 to 8. So we will have here the product rule, the quotient rule, the derivatives of trigonometric functions, and the derivative of the exponential function. Okay, let us have rule number 5, the product rule. So the derivative of the product of two functions is equal to, first, you will get the derivative of the first function, multiply it by the second function, plus you multiply the first function by the derivative of the second. So you consider this as the first and the second, and then you get the derivative of each of them and pair it with the function. So the derivative of f is being paired to g plus the derivative of g is being paired to f. You multiply. So we will have two terms here. For example, find the derivative of h of x equals 2x squared minus 1 times x cubed minus 4x. So this is our f and this is our g. So how do you get the derivative of this function? So as what it says, first, get the derivative of f, multiply it by g. What is the derivative of f? The derivative of 2x squared is 4x. The derivative of 1 is 0. That's why we have here 4x times g. So g is x cubed minus 4x. So copy that. Plus f. F is 2x squared minus 1 times the derivative of g. What's the derivative of x cubed? 3x squared, applying the power rule. Minus derivative of 4x is 4. And then we can expand this and simplify. 4x times x cubed is 4x raised to 4. Minus 4x times 4x is 16x squared plus we will multiply these two expressions. So we will distribute. 2x squared times 3x squared is 6x raised to 4. 2x squared times negative 4 is negative 8x squared. Negative 1 times 3x squared is negative 3x squared. And negative 1 times negative 4 is positive 4. And then we combine like terms. So what are the like terms here? We have 4x raised to 4 and 6x raised to 4 will give us 10x raised to 4. And then for negative 16x squared, negative 8x squared, and negative 3x squared, that is negative 16 minus 8 is negative 24 minus 3 is negative 27 x squared. And then just copy this plus 4. So the derivative of 2x squared minus 1 times x cubed minus 4x is 10x raised to 4 minus 27x squared plus 4. So in this case, we have here a product of two functions. So we apply the product rule. So again, derivative of the first times the second plus the first times the derivative of the second. Or actually, you can simply expand this and then get the derivative. So this h of x is 2x squared times x cubed. That's 2x raised to 5. 2x squared times negative 4x. That is negative 8x cubed. Negative 1 times x cubed is negative x cubed. Negative 1 times negative 4x is positive 4x. And then if you will simplify this, you can combine like terms. So that's negative 9x cubed. So copy the others and then take the derivative of this function h of x. So in this case, we are not applying the product rule. We are simply multiplying these two binomials here. And then the resulting function, we take the derivative of that. So the derivative of this is 2 times 5x raised to 4 because the derivative of this is 5x raised to 4. So 2 times 5x raised to 4 is 10x raised to 4. Here we will have negative 9 times 3x squared. So that is negative 27x squared plus 4. The derivative of 4x is 4. So as what you can see here, they're just the same. So this and this are just the same. So you can apply the product rule or expand the function. But actually, this alternative solution, you cannot do this if you cannot expand anymore, or sometimes if the given are not the algebraic function, which later in this video, I will give you some examples. So we cannot use anymore this expansion first. We really need to apply the multiplication or the product rule. Okay, let us have another example applying the product rule and finding the derivative. So h of x equals 4x cubed plus 2x squared plus 5x minus 3. Our f here is 4x cubed. And our g here is 2x squared plus 5x minus 3. So first, take the derivative of 4x cubed. What is the derivative of 4x cubed? That is 12x squared times g. So just copy this g plus copy f for x cubed times the derivative of g. So the derivative of this is 2 times 2x, that's 4x. And for 5x, that's 5. And for negative 3, that is 0. So we have this. And then we will distribute, expand, and simplify. 12x squared times 2x squared is 24x raised to 4. 12x squared plus times 5x, that's 60x cubed. 12x squared times negative 3, that's negative 36x squared. And then 4x cubed times 4x, that's 16x raised to 4. And 4x cubed times 5 is 20x cubed. And then combine like terms. So 24x raised to 4 and 16x raised to 4 will give you 40x raised to 4. And 60x cubed and 20x cubed will give you 80x cubed. And then this negative 36x squared, you just copy. So this is now the derivative of the given function. Or if you wish to expand this first and simplify, you will have 4x squared times 4x cubed times 2x squared, that's 8x raised to 5. 4x cubed times 5x, that's 20x raised to 4. 4x cubed times negative 3, that's negative 12x cubed. And then take the derivative of that. The derivative of 8x raised to 5 is 8 times 5x raised to 4. So that's 40x raised to 4. The derivative of this is 20 times 4x cubed. So that is 80x cubed. And the derivative of this is negative 12 times 3x squared. So negative 12 times 3x squared is negative 36x squared. So as what you can see here, they are just equal. This 40x raised to 4 plus 80x cubed. So if you apply minus 36x squared, if you apply the product rule or this one, you can get the same answer. So that's it for rule number 5. Later in this video, we will still apply this rule in finding the derivatives of others because we will have combinations this time. Okay, how about the quotient rule? So the formula is a bit more difficult, but not really. So if you have the quotient of two functions f and g, then the derivative of the quotient is this one. First, you get the derivative of the numerator, multiply it with the denominator, minus the numerator times the derivative of the denominator divided by or over the square of the denominator. For example, you're asked to find the derivative of h of x equals x plus 3 minus 2x, or I mean over 2x minus 1. So the numerator here is x plus 3, that is our f. And the denominator is 2x minus 1, that is our g. So in applying this quotient rule, you really need to memorize the formula. Okay, the derivative of the numerator is, derivative of x is 1. Derivative of 3 is 0. So 1 plus 0 is 1. And then copy g of x, the denominator, minus copy the numerator, and multiply by the derivative of the denominator. The derivative of 2x is 2. The derivative of negative 1 is 0. So 2 plus 0 is 2. And then expand and simplify. Over the square of 2x minus 1. So we will have 1 times 2x minus 1 is 2x minus 1 minus, expand this, x times 2, that's 2x, and 3 times 2, that's 6. So as what you can see here, we're still enclosed in pair parenthesis the product of f and g prime here. So because we will still distribute this negative sign. So if we will distribute negative sign, the positive 2x will be negative 2x, and the positive 6 will be negative 6. So we will have copy 2x minus 1, and then this will be minus 2x minus 6 over the square of 2x minus 1. And then 2x minus 2x is 0. And negative 1 minus 6 is negative 7. So here we have negative 7 over 2x minus 1 squared. So if you want to expand this 2x minus 1 squared, it's okay. But if your final answer is this, it will be fine. So that's it for the quotient rule. It's a bit long. Derivative of the numerator times the denominator minus numerator times the derivative of the denominator over the square of the denominator. Okay, another example. Find the derivative of h of x equals 3x minus 2 over x squared minus 4x. So f is 3x minus 2. G is x squared minus 4x. So the derivative of 3x minus 2 is 3 times the the denominator, minus numerator, 3x minus 2 times derivative of the denominator. Derivative of x squared is 2x. Derivative of negative 4x is negative 4 over the square of x squared minus 4x. So expand and simplify. 3 times x squared is 3x squared. 3 times negative 4x is negative 12x. Minus, then expand this. Just make sure you have to enclose the product in a parenthesis, so that in a pair parenthesis, so that you will still distribute you will not forget to distribute the negative sign here, the minus sign. Okay, so 3x times 2x is 6x squared. 3x times negative 4 is negative 12x. Negative 2 times 2x is negative 4x. And negative 2 times negative 4 is positive 8. And then simplifying this, we have, just copy this one first, minus 6x squared. Distribute the negative sign, negative 6x squared. This will be positive 12x. This will be positive 4x. And this will be negative 8 over the square of x squared minus 4x. And then combine like terms. 3x squared minus 6x squared is negative 3x squared. Negative 12x plus 12x is 0. Plus 4x, that is 4x. And then copy negative 8 and copy also the denominator. So the derivative of the given function is this one. Okay, let us have rule number 7, derivatives of trigonometric functions. So the derivative of sine x is cosine x. The derivative of cosine x is negative sine x. The derivative of tangent x is secant squared x. The derivative of cotangent x is negative cosecant squared x. Derivative of secant x is secant x tangent x. And the derivative of cosecant x is negative cosecant x cotangent x. So we will have these formulas by applying the limit definition of the derivative and applying the special limits. So after deriving these two, the a and the b, you can derive the others using this one. These two first. formulas. Okay, for example, find the derivative of f of x equals 3 sine x plus 2. So the derivative of 3 sine x, the derivative of sine x is cosine x. So 3 is just a constant multiple. And then the derivative of a constant is 0. So 3 cosine x plus 0, or simply 3 cosine x. Another example, find the derivative of g of x equals cosine x plus 3x minus x squared. The derivative of cosine x is negative sine x. So you will have negative sine x for cosine x. The derivative of 3x is 3, and the derivative of negative x squared is 2x. So as what you can notice here, we are still applying the differentiation rules 1 to 4, especially the power rule. Okay, here we have the derivative of f of x equals x tangent x. As what you can see here, this is a product of x and tangent x. So we need to apply here the product rule. What does the product rule say? Get the derivative of the first, so that's 1. Derivative of x is 1 times the second plus the first x times the derivative of the second. What is the derivative of tangent x? You have to memorize these 6 formulas. So the derivative of tangent x is secant squared x. So hence we have this one. 1 times tangent x is simply tangent x, and x times secant squared x is x secant squared x. So this is the derivative of x tan x. How about this? Find the derivative of g of x equals x cubed secant x. So as what you can see here, this is the product of x cubed and secant x. So we need to apply the product rule. So first, take the derivative of x cubed. So that is 3x squared times secant x plus, copy this one, times the derivative of secant x. And the derivative of secant x is secant x tan x. That's why we have this. Okay? So you need to apply the product rule and these formulas here. Okay, another example. Here, find the derivative of f of x equals x squared over cotangent x. So as what you can see here, this is a quotient, so we need to apply the quotient rule. So the quotient rule states that the derivative of a quotient is derivative of the numerator, 2x, times the denominator, cotangent x, minus numerator times derivative of the denominator. And the derivative of cotangent x is negative cosecant squared x. That's why we have this. Over the square of the denominator. The square of cotangent x is cotangent squared x. And then you can have this as 2x cotangent x. And then we have here minus, and then if you will multiply this, that's going to be minus negative. So plus x squared cosecant squared x over cotangent squared x. So we are applying here simultaneously the quotient rule and the derivative of cotangent x. Okay, rule number 8, the derivative of an exponential function e raised to x is simply itself. And we can derive this formula by applying the limit definition of the derivative and applying also another special limit that involves the exponential expression. Okay, find the derivative of 2e raised to x. So this is just a constant multiple. So 2 times the derivative of e raised to x. So 2 times the derivative of e raised to x is itself. So e raised to x, 2e raised to x. Find the derivative of negative 5e raised to x plus 4 x raised to 4. So you will have the derivative of this is negative 5 times derivative of this is e raised to x plus derivative of this is 4x cubed. Another, find the derivative of h of x equals x squared e raised to x. As what you can see here, we have a product, the product of x squared and e raised to x. So we need to pair the derivative of one to the other and express as a sum. So we have here derivative of 2 of x squared is 2x times e raised to x plus copy x squared times the derivative of e raised to x, which is itself. So this one. And we cannot simplify this further. So this will be the final answer. 2x e raised to x plus x squared e raised to x. Okay, another example, find the derivative of f of x equals e raised to x cosine x. So as what you can see here, we have a product. So we need to apply the product rule. So the product rule states that get the derivative of the first, so that's e raised to x, because the derivative is itself, times the second, cosine x, plus copy the first, e raised to x, times the derivative of the second. And the derivative of cosine x is negative sine x. Or you can express that as e raised to x cosine x. Plus, if you multiply this, this is going to be negative e raised to x sine x. Okay, another example, we will apply here this time the quotient rule. Quotient rule, derivative of the numerator itself times the denominator minus numerator times derivative of the denominator over the square of the denominator. So that's it. So you need to memorize that. Okay, so for practice, you can answer the following items. So we have here 4 items. We need to apply here the derivatives of trigonometric functions, the quotient rule, and the product rule. And of course, the derivative of the exponential function. So pause this video and answer on a sheet of paper. And later, if I'll reveal the answer, you can check your answers and write your score in the comment section below. Okay, let us check. So for number 1, the derivative of that is negative 3 cosecant x cotangent x plus 2. Because the derivative of cosecant x is negative cosecant x cotangent x. And then the derivative of 2x is 2. The derivative of negative 5 is 0. Here we need to apply the product rule in number 2. So first, a derivative of e raised to x is e raised to x times the second sine x plus copy e raised to x, and then derivative of sine x is cosine x. Okay, for number 3, we have h of x equals x squared plus 3 over cosine x. So we will have derivative of the numerator 2x times the denominator cosine x minus x squared plus 3 times negative sine x, which can be simplified to this one. And then over the square of cosine x is cosine squared x. And for number 4, we have derivative of 2x is 2 times e raised to x minus 2x times e raised to x over e raised to x squared. And we can factor e raised to x in the numerator and cancel it with 1 e raised to x on the denominator, and this will be the final answer. So if you got 4, you can comment down below. So that's it for this video. I hope you understood the differentiation rules, the product rule, the quotient rule, the derivatives of trigonometric functions, and the derivative of the exponential function. So that's it for this video. Thank you so much for watching. Bye!